Let's talk about interval notation. In this lesson, we're going to learn how to describe sets of numbers using interval notation. Now, it's all well and good when you have one solution to a problem. Like if the solution is x equals -4, we simply say x equals -4. Or even if there's a handful of solutions, if it's -4 and it's 1 and it's 3, okay, we can just list out the solutions. But what do we do if I want all the solutions between -4 and 3? I can't just say -4 to 3. That wouldn't make any sense. That's not proper mathematical notation. We need another way of doing it. Now, we should already be familiar with one way of describing intervals of numbers, and that would be set notation. But you also need to be familiar with another notation, and that's interval notation, so that given a particular situation, you can decide, do you want to describe it using set notation or do you want to describe it using interval notation? I'll tell you, sometimes it's quicker and easier to use set notation, sometimes it's quicker and easier to use interval notation. It will always be your choice which notation to use. Any competent mathematician should be able to quickly and easily decipher which one you're using. Now here we have an example of a bounded interval. A bounded interval is an interval that has two clear, finite, real number boundaries. We're going from -4 on the left side to +3 on the right side. You'll also notice that at -4 and at +3, I've got two clear filled in dots. That means I am including -4 in my interval, I am including 3 in my interval, and I'm including all possible numbers between -4 and 3. So as for my two possible ways of describing this, we'll start with set notation, the one you're probably already well familiar with, and that'll be this guy right here. You may not remember that this is called set notation, but I'm here to tell you, hey, this is called set notation. I've got my left boundary, which is -4, I've got my right boundary, which is +3, and then the x in the middle, which represents any possible number between -4 and 3. Notice it says right here that x is greater than or equal to -4, so x is greater than or equal to -4, but it also says right here that x is less than or equal to 3. X is less than or equal to 3. So you could say this as simply x is between -4 and 3. Now, if I'm simply saying x is between -4 and 3, it seems like there's an easier way to say that. Why do I even need all this fancy notation in the middle if I'm just saying x is between -4 and 3? Why don't I just keep the -4 and the 3, separate them with a comma, and say x is between -4 and 3? Here we have interval notation. So I would read this as the interval from -4 to 3. The interval from -4 to 3. Notice on the left side and the right side, I've got brackets. Brackets are my way of saying that I am including -4 and I am including +3 as part of my possible solutions. So this is the interval between -4 and 3, or you could say it's the closed interval between -4 and 3. I say closed because I'm saying I am including the endpoints. Anytime you want to include the endpoints, you can say closed, or you can just put the brackets and let the reader interpret. Now, what if I don't want to include my endpoints? Well, we know what to do with set notation. We just don't put the brackets underneath the inequalities. I'm still saying x can be between -4 and 3. I'm just saying that it can't actually be -4. It can't actually be +3. With interval notation, we'll do a similar thing to what we did before, but instead of using brackets, we use parentheses. So there's the key. Brackets mean included or closed. Parentheses mean excluded or open. Closed interval includes the endpoints. Open interval does not include the endpoints. Now, you may also look at this interval notation, parenthesis -4 comma 3 parenthesis, and you'll look at that without any context. You'll look at that and say, isn't that just the coordinate -4, 3? And I say, sure. Without context, anything can be anything. It's the context that makes things what they are. You have to pay attention to the context. If I'm talking about coordinates, then yeah, that's a coordinate. But if I'm talking about intervals on a number line, well, that's not a coordinate, that's an interval. Pay attention to the context, and it's always clear as day. And of course, your next question is, well, what if I mix and match? What if I want to include one side and not include the other side? I know what to do with set notation. Just put a bar on one side and don't put a bar on the other side. This one includes the -4. It does not include the 3. I understand that. Well, it's just as easy with interval notation. Remember what I said. Including, you put a bracket. Not including, you put a parenthesis. So you can mix and match your brackets and parentheses just like you can mix and match your inequality symbols. It's no different. You're welcome to do that. Now with this example though, we could neither call this an open or a closed interval because one side is open and one side is closed, so we just don't give it a special name like that. We simply say the interval from -4 to 3, including the -4, excluding the 3. So that covers situations where we have bounded intervals. What about unbounded intervals? An unbounded interval is where we have a clear boundary on one side, but then it goes forever in one direction. In this case, I'm describing all the numbers that are greater than -4. So with set notation, we're, again, very well familiar with this. X is greater than or equal to -4. Looks like this on a number line, looks like this in set notation. X is greater than or equal to -4. But what you have to realize is, even though it's technically unbounded, you are welcome to think of it as bounded. The left boundary is -4. We still have -4 on the left, so what's the boundary on the right? At this point, you may or may not have realized what the right side boundary is. If you haven't, it's infinity. Now, technically, infinity is not a boundary because you can never actually reach infinity. But for the purposes of our notation, we can treat it as a boundary. -4 on the left, infinity on the right. So, interval notation, -4 on the left with a bracket because it's closed, infinity on the right. Now notice we've got a parenthesis with the infinity because, again, you can never actually reach infinity, so you can never actually include infinity. Infinity will always have a parenthesis. Never, ever, ever put a bracket on infinity. It will always be a parenthesis. Now, just for kicks, I always like to point out here that you could actually use this bounded style notation with the set notation as well. Again, X is always in the middle. We always have the arrows pointing to the left. The left boundary is -4. The right boundary is infinity. And of course, bracket or bar underneath, including the -4. Now, notice what I have here. If I just look at this part right here, that actually says the same thing here. X is bigger than -4. X is bigger than -4. We just, when we're doing set notation, we typically don't include the infinity statement because it's implied. With interval notation, I have to have two numbers, smaller number on the left, bigger number on the right. If it gets forever bigger would be infinity. And of course, I can do the same thing if I'm going to the left. Why don't you go ahead and pause right here, since you should have the idea by now. Tell me what the set notation and the interval notation would be for this guy, and then hit play when you're ready. So hopefully it was obvious the set notation. 0 is my boundary and I'm going to the left, so I'll say X is less than 0. No, not including the 0, so no bar under the inequality. Interval notation, I have to think of this as left side, right side. There are boundaries. The left side boundary should have been -infinity. The right side boundary is 0, so -infinity to 0. Remember, parenthesis is always on infinities, whether it's positive or negative, and in this case we are not including the 0, so we have a parenthesis on that guy. So the interval, the open interval, from -infinity to 0. So what about situations where I have multiple intervals on a number line? Again, you've seen this before in your mathematical career, where I'm solving for x and I have all values that are less than a number and greater than a different number. Here we have x should be less than -2, not including the -2. We should have x is greater than 5, but this time including the 5. So we have our statements that we know how to state separately. Together, we simply throw in the word or. Because remember, think of this as the original question being, what is x allowed to be? Well, x is allowed to be less than -2, or x is allowed to be greater than or equal to 5. So that word or should make perfect sense. Now, when we're doing interval notation, we're going to approach this the same way. We're going to think of this as two separate intervals, two separate bounded intervals. On the left side, we've got a left boundary at -infinity, our right boundary at -2, so we have an open interval between -infinity and -2. On the right side, our left interval is at 5, our right interval is at infinity, so from 5 to infinity, this time we don't use the word open or closed because it's both open and closed on 5, open on infinity. But we're not going to combine it with the word or, we're going to use a fancy new notation like this. And no, that is not the letter U, that is the mathematical symbol for union. And Yes, you've guessed it, the word union in math means or. We use the union symbol to combine intervals that are non-overlapping. So anytime you have multiple intervals on a number line, just state each interval in order from left to right and combine them by using a union symbol. And pay attention to what I said there. We increase from left to right. The smaller intervals should be on the left, the bigger interval should be on the right. I should never see infinity and then see more words written. That makes no sense. Infinity is your period. It is the end of your sentence. If you keep talking, then you must not understand how numbers work. All right, here's another one. Why don't you take a crack at this one and tell me what you think? So the way you'd want to approach this one is thinking of it as not one long, open, unbounded interval with a number excluded, but thinking of it as a bounded interval between -5 and 3, and then an unbounded interval from 3 to infinity. So for my set notation, since I have a bounded interval between -5 and 3, I'll use the statement -5 is less than x is less than 3, open on both ends. And then with an or, I'll say my second interval, x is greater than 3. For my interval notation, all I have to do is essentially drop the x for the bounded interval, -5 to 3. Union, for my unbounded interval, it goes from 3 to infinity. So notice what I have here. If I ignore what's in the middle, you can kind of easily see that I'm going from -5 to infinity, but then I have that break in the middle to say at 3, I am not including that value. So I go from -5 to 3, union 3 to infinity. I've got parentheses on the 3 to indicate I am not including 3 in my interval. So what about this one? Here I'm saying I'm going all the way to the left, I'm going all the way to the right, I'm actually using all the values on the number line. In set notation, the way we say we're using all the values on the number line is this symbol right here. That symbol means all real numbers. Anytime you want to use every possible number that's on the number line, all you got to do is put that R. Now, since I know you're handwriting this, while I have a computer program, when I'm handwriting that R, typically what I'll do is I'll put 2 vertical bars like that, and then I'll draw the rest of my R like that. So sometimes I call this R with a double spine. Anytime you hear me say R with a double spine, that's what I'm writing, but that's what I mean to write, and that's what it actually means, all real numbers. Now for interval notation, remember with interval notation we always think of it as a bounded interval, so we always have a left boundary and a right boundary. In this case, the left boundary would be -infinity, and the right boundary would be positive infinity. So our interval notation is -infinity to positive infinity. Now you could say the open interval from -infinity to positive infinity, but it's kind of implied because you can't have anything other than an open interval from -infinity to positive infinity. Now here's one of those situations where as I said at the beginning, I don't care which notation you use. You can use set notation or interval notation. It's your choice. I typically default to interval notation because it allows me to just say exactly what I need without too much extra random notation. If I want to say from -2 to 5, I'm just going to say -2, 5 and be done with it, instead of having like -2 is less than x is less than 5. But with all real numbers, it's so much easier to use this symbol than to write -infinity to positive infinity. It's personal preference, but typically when I want to say all real numbers, I'm just going to say this. I'm not going to say this too often. But again, I don't care. All right, here's another common situation where we actually have all real numbers again, except there's one value right here that I don't want to include. In this case, x equals 3. I don't want to include that value. I want every other number except x equals 3. With set notation, we would say it like this. All real numbers, so there's my R with a double spine, all real numbers, comma, x cannot equal 3. So what I'm saying there is I can have any number I want to have as long as it's not 3. With the interval notation, remember, always thinking of this as bounded. If I have a break in my graph, that means I have 2 intervals. I have the interval on the left, which is bounded from -infinity to 3, and then I have the interval on the right, which goes from 3 to infinity. So -infinity to 3, open interval because I am not including 3, union 3 to infinity. Notice there's that union again because I have 2 separate intervals. Now another way to think of this that may be helpful in these situations where I just want to exclude a single number, sometimes what I do is I think of this to start with as, what if it was all real numbers? Well, it's going from negative infinity to positive infinity. But I have that break in the middle. Where is that break? That break is at 3. So at 3, I'm essentially adding this piece right here. So this piece right here tells me I have a break at 3. I'm not including 3. Left boundary is, my ultimate left boundary is negative infinity. My ultimate right boundary is infinity. But I have that break at 3. So I break up my interval with that 3 union 3 piece. Now essentially I've covered all possible types of situations that you're going to see. Now I'm just going to throw a few at you. Pause here, give your answer to the question, both a set notation and an interval notation for this interval, and then hit play when you're ready. So here we have an example of a bounded interval. We're going from -6 to +1. For my set notation, I know I'm going to have this piece in the middle. I know I've got -6 on the left. I know I've got 1 on the right. It's closed on 6, so I'll put a little bar. Set notation. For my interval notation, I'll essentially drop all that stuff in the middle. -6 on the left, 1 on the right, bracket on the -6, parenthesis on the 1. Set notation, interval notation. Here's another. Pause here, play when you're ready. Here's our open interval. Left endpoint is at -1. So with my set notation, I can say that x is greater than or equal to -1. For my interval notation, I take into account that my right side is bounded by infinity. So -1 to infinity, always parenthesis on infinity, and in this case we'll have a bracket on the -1. Here's another. Pause here, play when you're ready. Alright, here's one where we have multiple intervals. We've got interval number 1, interval number 2. So for my set notation, I'm going to be going from -6 to -2, or here my boundary is at 1, so x could be greater than but not equal to 1. So -6 is less than or equal to x is less than or equal to -2, or x is greater than 1. Turn those into intervals. We'll just drop the piece in the middle, -6 to -2, closed interval, so brackets. And on the other one, we're going from 1 to infinity. So 1 comma infinity, open on both sides. Don't forget, union in the middle. Here's another. Pause here, play when you're ready. Alright, this should be an easy one again. Notice I've got a situation where I have all real numbers except for 0 and 1. So I'm just going to say all real numbers, x cannot equal 0 or 1. Notice I have multiple x values that I can't have it equal to, so just like I do when x can equal multiple numbers, I just use a comma to separate. So with the interval notation, keep in mind I have 1 interval, 2 interval, 3 intervals. Anytime I have a break that breaks my 1 interval into 2 intervals, the fact that I have 2 breaks, 1 at 0 and 1 at 1, means my 1 interval is actually breaking into 3 separate intervals. So my leftmost interval will go from -infinity to 0. So -infinity to 0, open on both sides, union. My second interval will go from 0 to 1, so 0 to 1, another union. And then my third interval will go from 1 to infinity. 1 to infinity. So notice what I have here as I read it from left to right. My ultimate left boundary is -infinity. My ultimate right boundary is positive infinity. I have a break at 0. And I have a break at 1. Alright, now let's put that new knowledge of interval notation to work by solving some equations that involve inequalities. So here I have 3 equations for you to look at. You can either, if you already remember how to do all this stuff, go ahead and go through all 3, hit play, and then you can make sure that your answers are correct. Otherwise, we can just go through one by one. So the first one, we have an example of a linear inequality, x is to the first power. So I'm going to simply solve this using linear techniques. My goal is to get x by itself, so first thing I'm going to do is get rid of that 5. It's a positive 5, so I will subtract 5 from both sides, leaving me with -2x is less than 2. My goal is still to get x by itself. X is being multiplied by -2, so I will divide by -2. But at this point, hopefully you remembered about that little rule that we have about inequalities. Anytime you multiply or divide by a negative value, you flip the inequality. Less than becomes greater than, so we now have x is greater than -1. Now that's my set notation for the solution, but the directions call for interval notation, so let's convert that unbounded interval to interval notation. If it helps, feel free to visualize off to the side. If I have -1 right here, I'm going to the right. So this would be the interval I'm looking for, which means -1 is actually my left boundary. Infinity would be my right boundary. So -1, comma, infinity. And then as far as brackets versus parentheses, infinity is always open. In this case, -1 is also open, so we have a completely open interval. Open interval from -1 to infinity. All right, here's the next one. Feel free to pause here, try it on your own, and then hit play when you're ready. So just like the last one, the goal is to get x by itself. We'll start by adding 4 to both sides. That gives us 5/3 x is less than or equal to 10. Then our next step, just like before, let's divide by the number in front of the x. So we have division by 5/3, division by 5/3. But hopefully you went to 3rd grade and you learned that division by fractions is not very pretty. Instead of dividing by the fraction, we multiply by the reciprocal. So in this case, instead of dividing by 5/3, let's multiply by 3/5. So notice on the left that the 3 cancels out and the 5 cancels out, so we're just left with x. And on the right, 10 times 3/5. Remember that you can do that in multiple ways. You can either do 10 times 3, which is 30, 30 divided by 5, which is 6, or you can do it 10 divided by 5 is 2, 2 times 3 is 6. It doesn't matter how you get there as long as you get there. So x is less than or equal to 6, or -infinity to 6 closed on 6. And our last one. Here we have an example of a compound inequality. So we already have the setup where I'm basically implying that x is between two numbers. I just need to get x by itself. Just like we always follow for all equation rules, whatever you do to one side, you do to the other side. In this case, think of it as 3 sides. Whatever you do to one side, you do to all 3 sides. Pause here, play when you're ready. So the goal is to get x by itself. I've got -3 in division by 2. Based on the order of operations, the first thing I need to do is get rid of that division by 2. So to get rid of division by 2, I will multiply everything by 2. That gives us -2 is less than x minus 3 is less than or equal to 8. Keep that trick in mind. Anytime you are trying to get rid of a fraction, just multiply everything by the denominator, fraction goes away. Anytime you are getting rid of a fraction, multiply by the denominator, fraction goes away. So one more step, get x by itself by adding 3 to all 3 sides. When I do that, I get 1 is less than x is less than or equal to 11. So interval notation from 1 to 11, closed on 11.